Close your eyes for a moment. Take a deep, slow breath. Imagine the sheer weight of the world slipping away from your shoulders, dissolving into the endless quiet dark of the cosmos. Space seems frightening, but in reality, it is a cradle of infinite peace. Today, we are leaving the noise of the city behind. We are traveling far beyond our blue world, past the rocky shores of Mars, out into the deep, freezing, yet beautiful expanse of the outer solar system. We are searching for a paradox, a giant so massive it could swallow hundreds of Earths, yet so gentle, so unbelievably light, that it hides a secret most people never truly grasp. You do not need to be an astronaut to experience this. You just need to listen. What if I told you that Saturn, the majestic Lord of the Rings, could float in a pool of water? It sounds impossible. It sounds like magic. But it is pure, poetic science. Let us drift together into the dark and uncover the secret of the floating giant. To truly understand this cosmic magic, we must look back at how we first perceived these wandering stars. When ancient philosophers looked up, they saw bright, steady points of light. They thought they were perfect spheres of solid crystal or burning rock. Centuries later, when Galileo Galilei pointed his primitive telescope at the sky, he saw Saturn not as a perfect sphere, but as a strange world with handles. It took years of observation and the evolution of science to realize that those handles were magnificent rings of ice and dust. But the biggest revelation came much later. As humanity learned to read the light bouncing off these distant worlds, we discovered a shocking truth. The outer planets were not solid rocks like our Earth. They were gargantuan spheres of swirling gas, ancient atmospheres holding secrets from the dawn of our solar system. We called them gas giants, and among them, Saturn stood out. Not just for its halo, but for a physical property so unique, it changed our entire perspective on how planets are built. The secret lies in a simple word: density, a concept that dictates the very rules of the universe. But how do we begin to measure a world we cannot touch? Let us start by approaching the giant. Imagine you are floating in the silent void of space. There is no sound here, just the steady, peaceful rhythm of your own heartbeat. Ahead of you, a pale golden sphere slowly grows larger. A vivid illustration for this moment would be a breathtaking view from the window of a silent spacecraft, watching the shadows dance across Saturn's swirling cloud tops. We often hear the myth that space is a dark, terrifying abyss, but here, bathed in the distant light of our sun, it is incredibly serene. Saturn is huge. It is the second largest planet in our cosmic neighborhood. Yet, as we draw closer, you must understand that what you are looking at is not a solid ground where you could land a ship. It is an illusion of solidity, a magnificent trick of gravity holding immense clouds together. So what exactly is this golden sphere made of? To find out, we must strip away our earthly expectations. Earth is heavy. It is made of iron, rock, and liquid oceans. But Saturn is a completely different kind of beast. It is a world built almost entirely of the two lightest elements in the entire universe, hydrogen and helium. These are the same gases that make up the sun, the same gases that fill balloons and make them drift away into the sky. Imagine an ocean of gas, stretching down for tens of thousands of miles. An ideal visual here would be thousands of glowing balloons rising softly into a dark sky, representing the lightweight nature of this giant. A common myth is that gas giants are just fluffy clouds all the way through, but as we will see, pressure creates strange realities. Still, the fundamental truth remains: Saturn is profoundly, deeply light. Now, let us introduce the concept that makes our cosmic paradox possible: density. Density is simply how much stuff is packed into a specific amount of space. Imagine holding a heavy iron cannonball in one hand and a fluffy sphere of cotton candy of the exact same size in the other. The cannonball is dense. The cotton candy is not. Earth is the cannonball of our solar system. It is the densest planet we have. Saturn, on the other hand, is the cosmic cotton candy. Despite its terrifying size, its matter is spread out, uncompressed, floating gently in the vacuum. A perfect illustration for this block would be a glowing scale balancing a tiny Earth with a massive Saturn, tipping surprisingly toward our small rocky home. It is a beautiful reminder that in space, size does not always equal weight. It is the nature of the matter that counts. What is the magical number that defines Saturn's lightness? It is a number that scientists use to explain buoyancy. Water has a density of exactly 1 gram per cubic centimeter. Anything with a density higher than 1 will sink to the bottom. Anything with a density lower than 1 will float on the surface. Our heavy rocky Earth has a density of about 5.5. If you dropped Earth into an impossibly large ocean, it would sink like a stone. But Saturn has a density of 0.687. It is less dense than water. Imagine this number softly glowing in the dark, floating on a serene digital screen. It is a mathematical guarantee of our floating planet. The myth that all planets are heavy rocks shatters completely right here. Saturn, the Lord of the Rings, is lighter than the water in your bathtub. And so we arrive at the famous thought experiment, the cosmic bathtub. Imagine a bathtub so unimaginably large that it stretches across millions of miles of empty space. A bathtub big enough to hold a planet that is 9 times wider than Earth. Picture the water inside it, calm, glassy, reflecting the light of 1,000,000 distant stars. A majestic visual for this block would be a giant porcelain tub floating in a nebula, filled with crystalline, sparkling water. We place our golden giant gently onto the surface of this water. We do not throw it, we do not drop it, we just let it rest there. What happens? Does the giant sink into the abyss? No, it bobs, it rests, it floats. It is a thought that brings an instant smile to the face of anyone who imagines it. A colossal world, bobbing like an apple in a cosmic bowl. Let us explore the physics of this gentle floating. Buoyancy is a beautiful force. It is the upward push of a liquid against the weight of an object. Because Saturn's overall density is less than the water's density, the water pushes up harder than Saturn pushes down. Imagine the sheer scale of the displaced water. A perfect illustration would be a slow-motion animation showing the waterline perfectly intersecting the pale yellow clouds of the planet, the rings reflecting off the rippling surface. There is a myth that gravity would instantly crush the planet into a heavy core if it touched water. But in our perfect magical thought experiment, we suspend the harsh rules of gravity just enough to watch the physics of density play out. The giant floats peacefully, an island of gas in an ocean of stars. But what about the rings? How would they react to this cosmic bath? The rings of Saturn are not solid hoops of plastic. They are billions of individual pieces of water ice, dust and rock, ranging from the size of a grain of sand to the size of a mountain. If Saturn were floating in this gigantic tub, the rings would be an incredible sight. The icy chunks would meet the liquid water. Imagine a glorious illustration of glittering diamonds of ice, softly splashing into the cosmic ocean, melting slowly, creating a mist that wraps around the golden planet. The myth is that the rings would hold their shape, but gravity and water would pull them down into a dazzling, glowing soup of stardust and ice. It would be the most beautiful shipwreck in the history of the universe. Let us dive deeper into the golden sphere itself. Why is it so perfectly light? It all goes back to the birth of the solar system. Billions of years ago, when the sun was just a newborn star, it was surrounded by a massive disk of gas and dust. In the cold outer edges of this disk, things were quiet. Things were slow. Saturn began to form by sweeping up massive amounts of hydrogen and helium gas before they could be blown away by the solar wind. An illustration of this ancient past would show a majestic, swirling vortex of glowing purple and blue gas, slowly knitting itself into a giant sphere. The myth is that planets just popped into existence, but they were actually sculpted by the gentle, patient hands of gravity over millions of years. Saturn just happened to collect the lightest materials available. As we descend through Saturn's upper atmosphere, the illusion of a calm world begins to change. The top layers are freezing cold, peaceful, and beautifully painted with bands of yellow and gold. Ammonia ice crystals form high-altitude clouds. Imagine yourself gliding softly through these clouds, feeling no resistance, just a cool, golden fog surrounding you. A visual for this block would be a first-person view of gently falling through a brightly lit, honey-colored mist, with no ground in sight anywhere. We must debunk the myth that you could fly an airplane endlessly through Saturn. While it is light, the atmosphere gets thicker, heavier, and darker the deeper you go. It is a transition from an ethereal sky into a deep, crushing ocean of gas. As we drift further down, the pressure begins to build. The light from the sun fades, replaced by the glow of massive lightning storms that stretch for thousands of miles. The winds here are terrifying, blowing at over 1,000 miles per hour. Yet, from the outside it looks so smooth. This is the paradox of gas giants. A perfect illustration would show a split screen. On the left, the calm, perfect golden sphere. On the right, a raging, violent tempest of swirling grey and yellow clouds. Many people believe the myth that gas giants are just peaceful clouds, but beneath the surface, they are engines of incredible dynamic energy. But even with all this fierce pressure, the overall weight of the planet remains shockingly low. The math of density holds true. Deep down, thousands of miles below the yellow clouds, something strange happens to the hydrogen gas. The pressure becomes so intense that the gas behaves like a liquid. And then, even stranger, it begins to act like a metal. This is the layer of liquid metallic hydrogen. Imagine a dark, swirling ocean of liquid metal conducting electricity, generating a massive magnetic field that stretches far out into space. An illustration for this moment would be a glowing, pulsing, liquid silver core, crackling with unseen energy. It is easy to think of a myth that metal must be heavy, like iron on Earth. But this is hydrogen. Even in this compressed metallic state, it is still fundamentally light. It is a liquid that flows and shapes the planet, yet keeps its overall density lower than a raindrop. At the very center of this floating giant, there is a core, a dense hot heart made of rock, iron, and exotic ice. It is about the size of Earth, perhaps a little larger. This core is incredibly heavy. It is the anchor that holds the massive atmosphere together. You might wonder, if the core is so heavy, how can the planet float? Imagine an illustration of a tiny glowing red pebble, surrounded by a massive, fluffy cloud of cotton. The core is the pebble. The planet's massive volume is the cotton. A common myth is that a heavy core defines the planet, but it is the volume that matters. The amount of space Saturn takes up is so insanely huge that the heavy core is mathematically overwhelmed by the vast empty lightness of the gas around it. It is all about balance. Let us return to our giant cosmic bathtub for a moment. What would happen in reality if such a body of water existed in space? This is where our beautiful thought experiment meets the harsh reality of astrophysics. Water in the vacuum of space does not stay liquid for long. Without an atmosphere, water either instantly boils into vapor or freezes solid into ice. Imagine a stunning visual of a giant ocean suddenly shattering into billions of glittering ice crystals, floating away into the dark. We must debunk the myth that we could actually build this bathtub. Gravity would pull all that water into a giant, crushing sphere of its own, turning our beautiful tub into a new water planet. But that is the beauty of imagination. We can hold the laws of physics at bay just to appreciate the poetry of density. Speaking of water worlds, this brings us to an exciting realization. If Saturn is a giant ball of gas, are there planets out there in the galaxy that are actually giant balls of water? The answer is yes. As we look beyond our solar system, we find exoplanets called ocean worlds. Imagine a planet entirely covered in an ocean hundreds of miles deep, with no continents, no islands, just an endless dark blue surface reflecting the light of an alien sun. A visual for this block would be a smooth, sapphire blue sphere, glowing gently in the cosmic dark. The myth is that Earth is the only place with water, but the universe is practically drowning in it. These water worlds have a density closer to 1. They would not float in our imaginary bathtub. They would just blend right in. But what if we search for things even lighter than Saturn? Does the universe create planets that are even more ethereal, even more ghostly? Yes, it does. In the vast catalogue of discovered exoplanets, there is a category that sounds like a dream. Scientists call them superpuffs. Imagine a planet the size of Jupiter, but with the mass of just a few Earths. A perfect illustration would be a planet that looks like a giant glowing puff of smoke, almost transparent at its edges. The myth is that planets must be solidly packed, but superpuffs defy everything we thought we knew. They are so light, so incredibly uncompressed, that their density is not just less than water, it is less than a marshmallow. Let us travel in our minds to a specific place. About 2,600 light-years away, in the constellation of Cygnus, lies the Kepler-51 system. This system is home to 3 planets that hold the record for the lowest density ever discovered. They are the true cotton candy planets. Imagine gazing at 3 softly glowing orbs, looking bloated and hazy, gently orbiting a young sun. A beautiful visual would be a time-lapse of these 3 puffy giants, casting soft, diffuse shadows across each other. A common hymn is that we can only find heavy, rocky planets like our own, but the Kepler-51 planets have densities less than 0.1 grams per cubic centimeter. If Saturn floats like a heavy apple, these planets would rest on the water like a delicate feather. Why are these superpuffs so incredibly light? It is a story of youth and heat. The Kepler-51 system is very young in cosmic terms, only about 500 million years old. The planets are still hot from their violent formation. Heat makes gases expand. Imagine a pot of boiling water, watching the steam rise and spread out to fill the room. A great visual for this block would be a glowing, red-hot core surrounded by a massive, ballooning atmosphere of bright red and orange gas, actively pushing outward against the cold vacuum of space. We must debunk the myth that planets are static and unchanging. These young worlds are breathing, expanding, and slowly leaking their atmospheres into space. Over billions of years, they will shrink, cool down, and perhaps look much more like our own planets. How do we even know the density of a planet that is trillions of miles away? We cannot put them on a scale. We cannot drop them in a tub. We use the magic of starlight and shadows. When an exoplanet crosses in front of its star, it blocks a tiny fraction of the light. This is called a transit. Imagine a blindingly bright wall of light and a tiny, perfectly round shadow slowly creeping across it. An illustration for this block would be a graph drawing a gentle dip in a glowing line of light as the shadow passes. The myth is that we need to see the planet directly to know what it is. In truth, the size of the shadow tells us the size of the planet, and the tiny gravitational wobble of the star tells us its mass. Divide mass by volume, and the secret of density is revealed. Density is more than just a fun fact for a cosmic bathtub. It is the fingerprint of a planet's soul. It tells us the story of what the world is made of, without ever having to touch it. If a planet is small and dense, we know it is rock and iron, a place where mountains can rise and valleys can fall. If a planet is large and light, we know it is a world of endless clouds and crushing atmospheric deeps. Imagine a holographic projection of planets, sorting themselves into rocky spheres and fluffy clouds, based purely on their glowing density numbers. The myth is that astronomy is just looking at pretty pictures. The reality is that it is reading the hidden poetry of mathematics to uncover the true nature of worlds we will never visit. This understanding of density is our greatest tool in the search for the ultimate prize, a second Earth. When we look out into the galaxy, we are desperately searching for planets with a density of about 5. Planets that have a solid surface where liquid water can pool, where chemistry can spark, where life might just find a way. Imagine a slow zoom onto a distant star, revealing a tiny pale blue dot orbiting in the sweet spot, not too hot, not too cold. A vivid illustration would be the reflection of alien oceans sparkling under the light of an unfamiliar sun. We debunk the myth that every planet is a candidate for life. By measuring density, we filter out the gas giants and the water worlds, narrowing our gaze to the rocky shores that might harbor dreams. But we should not dismiss the fluffy giants, the floating Saturns of the universe. They play a crucial role in the cosmic ecosystem. In our own solar system, massive gas giants like Jupiter and Saturn act as gravitational shields. They swallow up dangerous comets and asteroids, keeping the inner rocky planets safe. Imagine a giant glowing net of gravity stretching out in the dark, catching icy debris before it can rush toward the sun. A visual for this block would be a breathtaking impact of a comet burning up in the thick yellow clouds of Saturn, leaving a temporary dark scar. The myth is that gas giants are just dead, useless weight. In reality, their massive presence helps create a stable, safe neighborhood where a small, rocky, dense planet like Earth can thrive in peace. As we drift back from the distant exoplanets and return to our own magnificent ringed giant, let us appreciate the sheer scale of the balance in the universe. Everything is exactly where it needs to be. The heavy, dense rocks hug close to the warmth of the sun. The massive, light clouds drift in the freezing dark. Imagine a beautiful, sweeping shot of the entire solar system, highlighting the delicate, elegant dance of the planets in their orbits. An illustration of this would be a golden clockwork mechanism, slowly turning in the dark, with each planet perfectly balanced by its density and speed. We must debunk the myth that the solar system is random chaos. It is a highly organized, naturally sorted system of matter, organized by the unyielding laws of gravity and heat. Think about the silence of Saturn. Despite the raging storms beneath the clouds, despite the millions of rocks crashing softly in the rings, space carries no sound. If you were floating just above the rings, you would hear nothing, just the profound, absolute silence of the vacuum. Imagine closing your eyes and feeling the deep, meditative quiet of this giant world. A perfect visual here would be a slow pan across the rings, lit softly by the sun, with the dark, empty void of space stretching into infinity behind it. Many hold the myth that space is filled with a roaring wind, but it is the ultimate soundproof room. In this silence, the concept of a massive floating planet feels not just possible, but incredibly peaceful, a giant sleeping in the dark. What would happen if Saturn slowly lost its rings? The rings are not permanent. They are slowly raining down into the planet's atmosphere, pulled by gravity and magnetic fields. In 100 million years, Saturn might just be a bare golden sphere. Imagine a future sky where the rings are gone, leaving only a faint, dusty halo. An illustration for this block would show the golden planet, looking strangely naked, orbited only by its dozens of small icy moons. The myth is that the rings have always been there and always will be, but the universe is a dynamic, changing painting. The floating giant we see today is just a snapshot in a cosmic timeline that stretches for billions of years. Let us picture the moons of Saturn, tiny worlds orbiting the giant. Titan, the largest moon, has a thick, hazy atmosphere and lakes of liquid methane. Enceladus, a tiny white moon, shoots geysers of water out into space. Imagine standing on the icy crust of Enceladus, looking up at the sky. Saturn would dominate your view, a colossal, glowing dome of yellow and gold, rings cutting across the blackness. A majestic visual for this block would be a first-person perspective from a snowy alien landscape, with the majestic floating planet hanging heavy and silent above the horizon. We must debunk the myth that moons are always dead rocks. Saturn's moons are active, mysterious worlds, completely dwarfed by the fluffy, lightweight giant they orbit. Why do we find so much joy in the thought of Saturn floating in a bathtub? Perhaps it is because it takes something terrifyingly huge and makes it relatable. It shrinks the incomprehensible scale of the universe down to the size of a household object. Imagine a child's toy boat floating in a tub, and right next to it, a glowing, ringed planet, bobbing gently. An illustration for this would be a whimsical, surreal painting of a massive bathroom, where the window opens up to the Milky Way, and the tub contains the solar system. The myth is that science must always be cold and calculating, but thought experiments like the cosmic bathtub show us that science is also playful, creative, and deeply imaginative. It invites us to dream. As we imagine this gently bobbing planet, we can also think about our own burdens. We carry the weight of gravity, the stress of daily life, the dense reality of Earth. But in the vastness of space, weight is relative. Density is just a physical state. Imagine your worries becoming as light as the hydrogen in Saturn's atmosphere, drifting up and away, lost in the massive clouds. A visual for this block would be dark, heavy stones, slowly turning into glowing, ethereal balloons and floating into a starry sky. We often buy into the myth that our earthly problems are the center of the universe, but looking at a world that defies weight reminds us of how small our troubles truly are. The cosmos offers a profound sense of release. The study of planetary density is not just about measuring rocks and gas. It is about understanding our place in the cosmic story. We live on the densest planet in the solar system, a heavy, solid anchor in a sea of empty space. But right next door, Jupiter and Saturn float like massive balloons. Imagine a golden thread connecting the heavy Earth to the light Saturn, symbolizing the delicate balance of our system. A beautiful illustration would be a glowing constellation map, drawing lines between the heavy hearts and the light minds of the planets. The myth that we are completely isolated is false. We are part of a diverse, beautifully balanced family of worlds, each with its own unique properties, each playing a role in the grand design. Let us take one final look at the giant in the bathtub. The water is calm. The golden planet rests peacefully. The rings reflect the starlight, glittering like a shattered mirror. It is a moment of pure cosmic zen. Imagine the soft, rhythmic sound of water lapping against the sides of the imaginary tub, blending with the deep, slow hum of ambient space. A perfect visual here would be a slow fade to black, leaving only the soft glow of the floating planet lingering in the center of your vision. We debunk the myth that you need to go to space to feel its magic. By just closing your eyes and understanding the simple, elegant math of density, you can transport yourself millions of miles away and find peace in the impossible. Our journey through the mechanics of density and the beauty of gas giants is coming to an end. We have seen how the lightest elements can build the largest worlds. We have traveled from our imaginary bathtub to the distant, puffy exoplanets of Cygnus. Imagine your ship slowly turning around, leaving the golden glow of Saturn behind, setting a course back to the heavy, comforting blue of Earth. A visual for this block would be a final, lingering look at Saturn fading into the black canvas of space, becoming just another star in the vast cosmic ocean. The myth is that space is empty, but we now know it is filled with wonders, puzzles, and floating giants waiting to be understood. And so we return to reality, back to our dense, rocky home. We have traveled far today, through oceans of stardust and the profound quiet of the outer planets. We discovered that Saturn, with its majestic rings and unimaginable size, is nothing but a gentle giant, a sphere so beautifully light it could bob in a cosmic bathtub. We learned that the universe is playful enough to create planets out of cosmic cotton candy, reminding us that reality is often stranger and more wonderful than fiction. I hope this journey has brought you peace and given you a new way to look at the night sky. The next time you see a distant star, remember that it might be shining down on a world lighter than a feather. Thank you for traveling with me through the dark. If you enjoyed this escape into the cosmos, please subscribe to the channel, leave a like, and tell me in the comments below, if you could build a cosmic bathtub, which planet would you want to put in it?